My name is Harold Carlson Farley, Jr., and I was raised under the name of Carlson. When my wife gets serious, she calls me Carlson, but everybody else calls me Hal. And I got that from the military as being Harold to Hal. Skunk Works. Back in 1943, I believe it was, the United States Air Force realized that the Germans were fielding a new jet airplane called the Me-262, a twin-engine jet that was capable of reaching our long-range bombers, the B-17s. So they felt that they needed a jet airplane. We needed a jet airplane for the Air Force. And so they contacted Lockheed for the job. I'm not sure exactly what their motivation was to come to Lockheed, but Kelly Johnson was a pretty well-known airplane designer and had been instrumental in the P-38, which was a first frontline fighter in the war. Anyway, they came and they said, we need an airplane in 5 months, a jet airplane in 5 months. And Kelly Johnson, who was a well-thought-of young engineer who had a very strong personality and a great amount of leadership capability and very strong man. He said, I'll take on the job. It has to be done by my rules. He had 14 basic sets of rules. I can't name all 14 of them, but 2 or 3 of them are important. 1, he gets to select the very best people he has in the whole company. Number 2, he reports directly to the company president. 3, nobody else interferes with the project at all. It's his project, and he's the boss, and the rest of the people in the Skunk Works are workers. So anyway, that's the rules that he set up for taking on that project. And it took the Air Force a month to deliver the proposal, but in the meantime, he'd already started working on the airplane, knowing full well he was going to be doing it. And they managed to deliver the airplane in 143 days. That comes out a bit shorter than 5 months, 4 months and some days, which was pretty phenomenal when you think about it. And it was a pretty advanced airplane. It was the XP-80 and made its first flight in 1943. And the pilot at controls was a fellow by the name of Milo Burcham, who was later killed in an accident. That was how the Skunk Works got its start and its reputation of being able to do a job quickly, on time, and under cost. Well, the name Skunk Works was from the Little Abner comic strip where, can't remember the character, but he was up in the woods and he would brew up this Kickapoo joy juice, some white lightning, I guess, and it smelled bad. And there were some odors that were in the hangar area of Burbank there. And so one day, one of the engineers answered the phone and said the Skunk Works, which was spelled S-K-O-N-K. And everybody started calling it Skunk Works, but the creator of Little Abner said, no, you can't use that. And went to court over it. I guess we probably conceded. I don't remember if there's any details of that, but we changed from Skunk Works to Skunk Works, and that's stuck, and we've always had the emblem of a skunk on the tail of the airplanes. The year I joined the Skunk Works was 1978, and I joined because I had been working with a fellow, Dr. Ken Stewart. He had a PhD in plasma physics, and he and I had been working on a new head-up display for the F-14. I was working for Grumman at that time, and unbeknownst to me, was also assigned to the head-up display for the new stealth fighter that was being developed at the Skunk Works. I read in the newspaper, in the Los Angeles Times, a very short paragraph that said a pilot had been injured in the desert. His name was William Park, and there was no details in that little thing, that little clip. And I always remember reading that and realizing or thinking that's very unusual. There's something going on up in the desert that they're not telling anything about, but they had to say something about the accident. It was my future boss who was in that accident, and he needed a pilot because he had injured himself pretty bad. He had asked some people around, and Ken Stewart recommended me. He called me one day. He was very abrupt on the telephone. He said, "My name's Bill Park." He said, or would you be interested in a job at Lockheed? And I said, well, you'd have to tell me something about it. Well, he said, it's at the Skunk Works. You know, the Skunk Works is a magic word among pilots, and I was immediately interested when he said that. I said, yeah, I would be interested if you could tell me something about it. He said, well, I'll call you back. And that was the end of that conversation. And for about 3 weeks, I figured it went away and wasn't coming back. But he did call me back, and he said, have you thought about it? I said, yeah. I said, I would be interested. And he said, all right. He said, I'd like for you to come down for an interview. He said, but I don't want you to come to the company. I want you to come to my house. And so I said, okay. He gave me the address, and it was down in Westwood. And the house was on the golf course in Westwood, down in the high rent district of L.A. And it was a gorgeous home. And I mean, it was a beautiful home, and there was nobody there. His wife wasn't there. She was somewhere else. And he greeted me, and I came in, and we had our chat. And when I left, I said, man, those guys must pay a lot of money. Turns out that Bill and his wife were really good at real estate. But that was how I got introduced to the Skunk Works. It took about 3 months to get a clearance. I had a secret clearance from Grumman, but this was secret special access required, which is a couple of levels above secret to be able to access the program. So I was placed in the penalty box, they called it, until the clearance came through. And then when it came through, they then could introduce me to what it was we were going to fly. And I remember Alan Brown was one of the senior engineers, and he took me into a room, and the drawings were up on the wall, regular blueprint drawings, and he said, what do you think of that? And as you know, it's a very unusual looking airplane, and it's very highly swept angles. And my first thought was the darn thing must be a re-entry vehicle. It had to be something like that. And then he explained it to me what it was for, that it was to evade radar. And I really didn't pick up on how important that was at the time. I thought that was, okay, good, it's to evade radar. How well does it fly? Is it a real fighter? Can we shoot things down with it? You know, what a pilot wants to do is be able to maneuver his airplane well, and it turns out the airplane is pretty, low performance, relatively speaking, to the current day fighters. And so that's how I was introduced to the airplane. And then I was assigned to the weapons system to work on the displays with my old friend Ken from Grumman, who was working down there at Lockheed and at Grumman at the same time. Well, the first prototype was on the floor. What was available was the wooden mock-up. They had a complete wooden mock-up, full-scale wooden mock-up they were using to do the wire runs in. This is really crude, manufacturing process quite a few years ago. But they were using this wooden mock-up to place displays in the cockpit, to locate boxes and, to see if they would fit. And we also had offices right alongside that, and we had people that were working on the displays, and I was assigned to the cockpit displays, and we had two other pilots that were working on other aspects of the airplane as well with the engineers. I think it was for two reasons. One, I had been a test pilot in industry for a number of years. The other fellows had come directly from the military. It isn't that you can fly any better. It's just that how do you deal with engineering and the company? And I was, I think, better prepared to do that than the Air Force guys that were, and another Navy guy that came in. I think that was one of the reasons. And the other reason is I worked like the devil. I worked hard because I wanted to be the project pilot on it. And I was selected. That's what I think was the reason. In order to be able to be the project pilot and the first flight pilot, the competition for that is intense. You want to be the guy that gets the job, and and you work hard. You work with engineering, you work with, and you're flying. We are flying at the time. We were flying airplanes like T-38s, and so you're being evaluated by the boss and also the customer. It is something that I don't know how to describe it any other way. It's an intense process. The secrecy, the classification of the program was at the same level as the Manhattan Project. That was how secret it was, and it was very successful. If you recall, we spent many years working and actually having the airplane in operational readiness, and not many people knew anything about it. And so it was highly classified, remotely developed, a lot of time away from family. We spent usually 6-day weeks, and we would leave home and come back after Friday or Saturday night, and then turn around and go back out Monday morning. For, well, I guess probably the first year and a half was that we were separated that much. My wife knew I was flying. I mean, that was my job, but that was all I could tell her. I couldn't tell her what I was flying, where we were. We had a special arrangement, secure telephones, so we could call home through the office fairly regularly, and not have to worry, just to check in and see how everything's going as the hot water heater broken down or whatever. But yeah, it was pretty strenuous on the family life. People that I associated with know about the Skunk Works. They know you're going to say, "I can't tell you." There's nothing I can tell you about it. I can say this: the Air Force were flying A-7s as a cover airplane. They had a squadron of them at Nellis Air Force Base, which were supposedly working on some advanced system, and they were kind of secret. But that's where the Air Force was. They used the A-7 as their cover story. Our cover story was just simply we just didn't talk about it. The security that was established within the Skunk Works, the security or the classification culture of the Skunk Works, was developed by Kelly Johnson again. And back to a little bit about that initial airplane that he built, the XB-80 that started the Skunk Works. One of the requirements was it had to be top secret. And one of the reasons for that is it keeps other people out. That was one of the tools to keep other people from becoming involved with the program, from becoming a bureaucracy. So the Skunk Works security was established out of common sense. For example, if you put a guard out in front of a place, somebody's going to know something's inside. They didn't put any guards out. If you put secret or confidential on a drawing of an airplane, you're going to know it's a secret. Something's going on if somebody gets a hold of it. They didn't stamp any of the things classified at all. They didn't have any guards outside. They made it as normal as possible so as to not attract attention. They went so far way back when the satellites were first coming out, and they took all the names off of the parking places because they could find out who was working there. The enemy could find out who was working there, the enemy being the Cold War and Russia. The Skunk Works operated out of Burbank and has operated out of Burbank all the way back to the P-38, to the U-2, to the SR-71, to F-117. All of them have been built there and down in beautiful downtown Burbank, inside a big old World War II hangar. The airplanes were assembled there. Then the wings were taken off of them, and in the case of the F-117, they flew a C-5, which is the Air Force's huge cargo airplane. They'd fly it in the middle of the night, and they would take the phone calls for the noise abatement because there was always somebody in the neighborhood who didn't like the noise, but it only happened every now and then, so we kind of disregarded it. But anyway, they would make a box frame out of wood, 2x4s, and drape a tarp over it so it would not show any part of the shape of the airplane whatsoever. And they put it on wheels, and they would wheel it out, put it in the C-5, and then they would fly it off to where we would test the airplane. and was reassembled and then tested at a remote location. And that was done, in fact, back in the SR-71 days, they didn't have a C-5A to transport that around, so they developed a false front, if you will, for a truck line. Lockheed had a trucking company that was named some weird name, and it was on the back of those trucks that they hauled the SR-71 fuselage and wings to the test location. The first flight was a success, I'll say that, because we took off and we landed. But there were some problems that we encountered and some things we discovered that needed to be fixed. But let me go back just a little bit. The airplane is unstable in pitch and yaw. It can't be flown without the assistance of computers. At the lower speeds, it's about neutrally stable, which is almost flyable. One of the bits of information that goes to the computers to help fly that airplane is the air data that goes in the probes on the front of the airplane. And the engineers were afraid that the vibration of those probes on takeoff and in turbulent air might send vibrations to the flight controls and cause them to oscillate. And so therefore they did not want to use the air data on the initial takeoff. So what we did was we put a bunch of lead in the front of the airplane and made it positively stable, thinking that I could manage the airplane. It was still not real stable, but it was stable enough that we felt that I could fly the airplane satisfactorily up to 10,000 feet and then turn on the air data information to the computers so that if it did cause a problem, there would be plenty of room between me and the ground to get those things turned off again and bring the airplane back. That was the plan, and that's what we did. We took off, ballasted with lead in the nose so that it was slightly stable on takeoff, which was fine. The rotation and everything was good in pitch. It was that the fact that the airplane started to yaw, and it went out, I believe it was 6 degrees to the left, and then I tried the rudder to stop it, and it didn't respond right away, and then it slowly came back the other way and went out to around 12 or 13 degrees the other way, and that's very uncomfortable in an airplane to feel like you're skidding sideways. And so I realized that this thing wasn't acting the way we expected to act based on the wind tunnel and simulation that we'd done. Actually, I had 3 switches for pitch, roll, and yaw over on the left-hand console, and the yaw switch I had extended because that was the most critical one. And I turned on the air data so that it would come through the probes and go to the flight control computer to help me fly the airplane. And it did. It worked fine. There were no vibrations or anything like that. But they got turned on a lot quicker than we planned to do because we were going to go to 10,000 feet to turn them on. Based on that information, we realized that the fins on the airplane, the tail fins on the airplane were considerably too small. The wind tunnel data, I don't know how a mistake was made. Somehow, I believe I heard that they didn't take into full account the sting that the pole that you put an airplane in a wind tunnel on contributes to stability. And I'm not sure that's the case. At any rate, they came up with a figure that they said we were going to be more stable than we really were. So the fins were too small, and that was the big discovery on the first flight. And we flew the airplane 6 more times in a very limited flight envelope while they were building a new set of fins 50% bigger that were put on the airplane. And from that point on, we had the proper amount of stability. That was the big thing learned on the airplane. The minor problems that we occurred are not minor, really. We had overheat in the tailpipes because the tailpipes were rectangular, and in the corners, heat builds up. And they were reaching limited temperatures. And we also had the canopy unlock light that came on, and that was of concern because if the canopy had come off, you get a face full of wind, and it was marginal about whether you could land the airplane or not. And the other thing was that we heard a big thump, and that was the blow-in doors, which were spring-loaded and activated so that it gave enough air for the airplane on the ground, enough air to the engines to run properly, and then as you accelerated, more air came in the inlets, and then the doors would spring-load shut, making the airplane stealthy because you can't have openings in the airplane and be stealthy. And when they slammed shut, there was 2 very pronounced thumps that I hadn't anticipated, scared the heck out of me. But there was no indication in the control station nor on my instruments, so we continued on with the flight. The flight was only 15 minutes, limited by the temperature in the tailpipe. And that was basically the first flight, yeah. No, I've never had a UFO sighting.
Okay, that's good.
How we worked together at the Skunk Works and with our customer was absolutely critical to the success of that airplane. The airplane was a huge success. The program was a huge success. In the world of flight test, in the last 30, 40, 50 years, there's always been a aura of competition between the company pilots and the customer pilots, the Air Force pilot or the Navy pilot that's going to be getting the airplane. Ever since I started the testing business, I was a Navy test pilot for a long time, and then I became a civilian test pilot for Grumman, flying F-14 and A-6s, and it was always a us and them battle, you know. We felt like we could do it better as company pilots than they could. It was just kind of, I know, testosterone, ego, whatever you want to call it. It was always a scrap. And I learned from this experience that cooperation works a whole lot better than adversarial relationships. Kelly Johnson's, one of his basic rules was, we need to be allowed to test our product, otherwise we will never be able to, advance our products in the future. So he felt like he needed a corporate knowledge in the form of pilot experience in the airplanes that he built. And the Air Force has always felt that they wanted to do all the flying. It's always been a compromise. If you have a combined test force, typically the company does fly the first flight of the airplane and does flutter and does structural and does all that stuff, but the operational aspects are done by the customer, which I think is a good way to do it. But there's always a little bit of a conflict. But we had a very unique individual in the Air Force, a guy by the name of Skip Anderson, who was running the Air Force side of the test force. He had a very unique way of calming us company pilots down. He provided great leadership, and he worked well with Ben Rich, the head of the Skunk Works, and they got along great, and we saw that, and we all followed suit. And I give Skip a lot of credit for that. We got along very well. John Beasley was one of the Air Force guys, and he was just one of the team. We were all teammates. One of the criteria for working at our remote location is you had to get along. If anybody didn't get along, you were out of there. So teamwork and cooperation were fundamental to the success of the program. What does it take to make a good test pilot? I think one of the things is the basic flying skills need to be above average. I think that responsibility to the company and to the product are fundamental to being a good test pilot. I think involvement with the design and development of the airplane is critical to being a good test pilot. I think an engineering degree or advanced degree is, in this day and age, the kids that go off to the test pilot schools, they arrive there with master's degrees, and a lot of them go away with PhDs. They're way above me. I only had a bachelor's degree, but it's hard for me to say. I'm telling you about what I think I am. Am I an above average pilot? Yeah, I am. I can say that honestly. Am I one of those great stick and rudder guys like Bob Hoover, who was a phenomenal pilot, is a phenomenal pilot? I'm not one of those. But do I get involved with the project? I do. I get very involved with the project, or did when I was working. Well, first of all, if I were talking to my grandson, who they're all grown up, my great-grandsons, I would say first thing is honesty. Be totally honest. If you can't be honest, then you're going to tell somebody something that you did that you didn't do. And I learned that really early in test piloting game. Several people had made a mistake. It was a simple mistake. They left a switch in the wrong place, And if you took off an afterburner, you were dumping fuel and it would light up and you'd leave this big long torch behind the airplane. And I did that. And I came back and I convinced myself that that switch was in the right place and that I didn't switch it, but I did. And so I was embarrassed by that. I got caught with my hand in a cookie jar, and that was my real lesson in honesty. You have to be honest as a test pilot. You can't, if you made a mistake, man, you got to tell them, because otherwise they might blame it on the airplane, or they might, the manufacturing process may be changed, or the engineering process. I learned, as I mentioned in the last bit of discussion, that to work with people, you have to respect them, you have to respect their ideas, and you have to present yourself as their co-equal. Honesty, integrity, care for other people. In the world of test piloting, once a guy gets to be the chief test pilot, it is normal for the chief test pilot to go out and fly all the good stuff. And that was the way it was at Grumman. There was a man by the name of Corky Meyer for years was the chief test pilot, and anytime a goodie came up, a first flight or a bonus flight, we got extra pay if it was hazardous. The lead guy, the chief pilot, would end up going out and doing it. There was a fellow there that worked at Grumman, and I won't mention his name, became the chief pilot, and he did everything, and the rest of us were doing the dog work. And I said, if I ever get to be chief pilot, I'm going to share the load a little bit. And those guys, I got to be the first flight pilot. There's two other guys that were very lucky that I got to be the first flight pilot in the F-117. Because I said, if I got to be chief pilot, as I said, I would share. And I had two guys working for me we were very close, Dave Ferguson and Tom Morgenfeld. Dave was an Air Force guy. Tom was a Navy guy. When it came time for the F-22 to come along, I had plans. I was dreaming about sailing around the world, and I was getting to be, closer to 55. And so I said, I'm going to do what I said I was going to do, and I gave Dave Ferguson the project pilot job. I was the chief pilot and director of flight ops, but he was the project pilot and would be flying the first flight on the F-22. The day he went out and flew that first flight, I was out there watching it, and I was saying, man, I wish I had made that promise. But I was very envious of the day he got to fly. I would have been able to fly the airplane if I'd have just exercised my rights as the chief pilot. And then the next airplane, the F-35 that came along, Tom Morgenfeld got to fly the first flight. So each one of us got a first flight, and I'm kind of proud of that. We had T-38 Talons. We had A-7s. We had F-4s, all of which we could fly anytime we wanted to. And that was that was like the astronauts had. They had their airplanes were out there. Anytime you wanted to go fly, you can go fly. And it was good. It maintained proficiency. It wasn't just a good deal. And we did a lot of air-to-air stuff. And we'd go out and fight each other. That was very good for confidence and very good for proficiency. The F-14 flies like a small airplane. It's a big airplane, but it flies well. Flies small. I enjoyed the A4. The A4 is a little sports car. It's got 270 degree per second roll rate. Put the stick over and you're through 360 degree rolls about that quick. And of course the F-117, which turns out to be, we tailored the flight control system so well that it's very easy to fly. I mean, it feels just like a normal airplane, and one of the best of the normal airplanes. Like an F-15 is very easy to fly, very easy to land, very easy to take off, and excellent flying qualities. The reason that the F-117 was retired was because of the F-22. The F-22 is a high-performance airplane. It can do what the F-117 can do. It carries its weapons internally. It can deliver air-to-ground. It can deliver air-to-air. It can go supersonic. It can cruise supersonic. And it's aerodynamically shaped. And you notice it has curved surfaces, and the F-117 has flat surfaces. And the reason was when we designed and built the F-117, the original program was not nearly as sophisticated as the programs that are using now to predict and develop stealth shapes. And so we had to go with flat surfaces, flat and angles. So that's where they differ. That's just and the money required. And then there's rumor around. It was mentioned the other day by a friend of mine talking about Aviation Week had an article that they've seen an F-117 flying, and that would really make me feel good.
To build Have Blue, we needed $10 million. One can't imagine what goes through your mind when you have to ask the board of directors to invest $10 million at a time when the corporation was considering declaring bankruptcy. The $10 million investment brought the company several billion dollars of sales and a reputation of technical superiority and stealth technology. The advantages of low observables, or stealth technology, have been a military matter of considerable interest for decades. Applicable not only to aircraft, but to all other forms of military equipment as well. Attempts to camouflage or reduce the visibility of hardware and personnel have been ongoing since the beginning of recorded military history. During World War II, the application of camouflage paint patterns was studied with considerable intensity. Scientifically conducted research helped generate patterns that genuinely reduced an aircraft's visibility both in the air and on the ground. Polished aluminum, for instance, was criticized for its notable ability to reflect sunlight and increase the detection distance of a target aircraft. Dull, non-glare matte-type paints eliminated the problem, but not without increased expense and some cost in performance. The exigencies of war curtailed extensive research into the development of airworthy, non-radar reflective structural materials, but some attempts were nevertheless made. The Germans, in particular, placed emphasis on lowering the radar return of select aircraft, including the notable O-229. This extremely advanced all-wing jet fighter, built primarily of wood over a steel tube load-bearing structure, in some production models was to have utilized a wood sandwich ply with a core material of granulated charcoal. Presumed to have absorbed radar energy, the charcoal was calculated to reduce the aircraft's radar return by a not insignificant margin. The war ended before the technology could be fully exploited. Countermeasures were slow to develop initially, with little focus on reducing radar visibility or countering radar energy during the 1950s and 1960s. It wasn't until the Vietnam War that effective electronic countermeasures were pursued. The threat of radar-guided missiles required a reassessment of technology, leading to the development of ECM pods and chaff dispensers. Lockheed gained experience in anti-radar features through programs like the U-2, A-12, and SR-71. In 1974, DARPA requested studies for a low observable fighter, excluding Lockheed, but they were eventually included through the Skunk Works efforts. Lockheed refined external shaping techniques using Echo 1, a computer program predicting radar cross-sections, or RCS, based on mathematical formulas. They employed faceting, creating a three-dimensional aircraft from flat panels to reduce RCS. Validation testing was conducted with a model called the Hopeless Diamond, demonstrating lower RCS than previous designs. In August of 1975, Lockheed, along with Boeing and Northrop, received invitations from the Defense Advanced Research Projects Agency to participate in a highly competitive project known as the Experimental Stealth Test Bed. The objective of this project was to develop and test an innovative aircraft design with exceptional low observability characteristics. After a thorough evaluation process, Lockheed was selected in April 1976 to proceed with the detailed design, development, and testing of the aircraft, which was named Have Blue. A single-seat subsonic aircraft featured a distinctive design aimed at achieving both high maneuverability and low observability. A significant feature of the aircraft was the inclusion of a large two-position flap known as the platypus, which automatically deflected downward when the angle of attack exceeded 12 degrees, enhancing the nose-down pitch control. The initial engine runs were accomplished on the first Have Blue aircraft on November 4, 1977, at Lockheed's Burbank facility. In order to maintain security, the aircraft was parked between two semi-tractor trailers over which a camouflage net had been installed. On December 1, 1977, with Lockheed test pilot Bill Park at the controls, Have Blue lifted into the air. A new era in military aviation had just begun. Only 20 months had passed since contract award. As previously noted, the primary objective of the test program was to demonstrate VLO technology. Towards this end, Have Blue 1001 would demonstrate loads flutter, performance handling qualities, and stability and control. Have Blue 1002 was designated as the PCS test vehicle. Have Blue 1001 accomplished 36 flights over the next 5 months and successfully expanded the flight envelope sufficiently to allow the RCS testing to be performed. Have Blue 1002 joined the program during 1978 and flew for the first time on July 20th with Air Force pilot Norman Ken Dyson at the controls. This aircraft differed from Have Blue 1001 in that it possessed a real airspeed system and did not have a drag chute installed. It also incorporated nose wheel steering to improve ground handling and was adorned with all the coatings and materials required to perform its intended task. Following some airspeed calibration flights, the aircraft accomplished 52 flights during the next 12 months and completed the low observable testing. The final phase of testing in a simulated integrated air defense environment was completed during July of 1979. The aircraft demonstrated its low observable capabilities against ground and airborne systems during these tests. Its low acoustic signature was also verified. The Have Blue program was a low-cost demonstration of a radically new concept in VLO aircraft design. Have Blue program accomplishments included, from a technical standpoint, lowest RCS aircraft in the world by several orders of magnitude, VLO infrared signature, VLO visual signatures, VLO acoustic signature, and confirmation of complex aerodynamics. In conclusion, it was determined VLO tactical and strategic aircraft could be designed, produced, and operated.
I always felt it would perform very well, but I never expected it to perform as well as it did. We had not involved the airplane operationally, and therefore the operators didn't know how to use the airplane. It's like having a new tool. I was worried we hadn't operated it enough.
On the evening of January 16th, 1991, television viewers who tuned into CNN witnessed a rare live preview of future wars. Correspondents Bernard Shaw and Peter Arnett, broadcasting from the room in Baghdad's Al-Rashid Hotel, reported on Iraq's state of alert under Saddam Hussein.
Something is happening outside. Peter Arnett joined me here. Let's describe to our viewers what we're seeing. The skies over Baghdad have been illuminated. We're seeing bright flashes going off all over the sky. Peter?
Well, there's anti-aircraft gunfire going into the sky. However, we have not yet heard the sound of bombs landing, but there's tremendous lightning in the sky.
I have a sense, Peter, that people are shooting towards the sky, and they are not aware or cannot see what they're shooting at. This is extraordinary. We're getting starbursts, seeming starbursts in the black sky. We have not heard any jet planes yet, Peter.
No plane. Now the sirens are sounding for the first time. The Iraqis have informed us.
5.5 months after Iraq invaded Kuwait and 17 hours past the coalition's withdrawal deadline, Baghdad was shielded by the world's densest air defenses. This included 76 surface-to-air missile launchers, or SAMs, and nearly 3,000 anti-aircraft artillery guns. Iraqi radar operators scanned the moonless sky for signs of incoming aircraft, but saw nothing. Shaw remarked, "We haven't heard any planes yet," speculating if the B-52 bombers flew too high to detect. 650 miles to the south, at Khamis Musheit, in southwestern Saudi Arabia, U.S. Air Force pilots of the 37th Tactical Fighter Wing were also glued to CNN's broadcast. 2 hours earlier, some of their squadron members had taken off from King Khalid Air Base for the war's first airstrike. One of their objectives, located on the west bank of the Tigris River, was the 370-foot Al-Kark communications tower, which transmitted CNN's signal to the outside world. As the estimated time of the strike neared, everyone at King Khalid kept one eye on CNN and one on their watch, counting down. If all went as planned, the network would go dark. Now. The need for an aircraft capable of penetrating modern air defense systems had actually emerged from another Middle Eastern conflict almost 20 years prior. During the 1973 Yom Kippur War, Israeli-flown McDonnell Douglas F-4 Phantoms were heavily impacted by Egypt's radar-guided SA-6 SAMs. At the same time, in Vietnam, the U.S. Air Force was dedicating more than half its aircraft to radar suppression instead of bombing. The first real solution to these challenges came in 1975 from the most likely source, Lockheed California's Advanced Projects Division, the renowned Skunk Works. Engineers there realized that curved surfaces reflect energy in multiple directions, like how a soap bubble reflects sunlight. However, if an aircraft had flat surfaces, like the facets of a diamond, reflections could be directed away from the enemy receivers. Faceting led to handling difficulties for pilots, prompting Skunk Works team leader Ben R. Rich to secure government funding for 2 full-sized prototypes under the purposely vague codename Have Blue. Because the aircraft provided near immunity to radar, the Air Force quickly funded the production of full-scale development, or FSD, models. The new design incorporated lessons from the Have Blue program, including increased engine power. The inlets and exhausts were baffled and soundproofed. Reducing noise instead of the typical jet turbine roar, the plane emitted a high-pitched whine that could set dogs barking before it even appeared. The inward-canted fins of the prototypes had reflected heat emissions, so the FSD models featured outward-canted fins in a V-shaped butterfly tail. Combat requirements modified by the need for stealth influenced the rest of the redesign. Unlike most military aircraft since the 1950s, the plane carried no radar, as even an inactive radar acts as a reflector. Even the standard radio antennas found on conventional aircraft were designed to retract beneath the plane's surface when not in use. Additionally, since external fuel tanks and weapons would negatively impact the plane's radar cross-section, or RCS, all fuel and munitions were stored internally. Over the next decade, the stealth fighter, as it was popularly known, became a major topic of discussion in the aviation world. The new aircraft was assigned the code name Senior Trend and the misleading designation F-117. Test flights were mostly conducted at night, scheduled to avoid detection by Soviet reconnaissance satellites.
The Nellis Range, also home to the Air Force's Red Flag air combat exercises involving American and Allied military aircraft, maintained a security screen to keep the other aircraft away from the Grumman area. Despite the F-117 being 33% larger than the prototype, its radar cross-section, or RCS, measured between 0.01 and 0.001 square meters, roughly equivalent to that of a small bird. This allowed the F-117 to approach ground-based search radars 90% closer and airborne radars 98% closer before detection. Testing was still ongoing when the Air Force ordered a full wing of the production version of Senior Trend, designated the F-117A Nighthawk. The first military pilot to fly a Nighthawk was Lieutenant Colonel Alton C. Whitley, a Vietnam veteran with combat experience in the A-7 and North American F-100, and a former commander of the Air Force's Aggressor Squadron. He recalled, "When I first looked at the F-117A, it reminded me of some Star Wars type of aircraft. I thought, boy, is this the 21st century?" Normally, the Nighthawk's fly-by-wire system managed its instability so well that when one jet lost an entire rudder at high speed, the pilot only learned of it from the chase plane, yet landed safely. With low wing loading and G-limits comparable to the F-4, the F-117 reportedly handles well. The wildly publicized nickname Wobbly Goblin stems from its departure characteristics. Once it loses control, recovery is nearly impossible. In June 1986, and again in October 1987, Nighthawks crashed into the ground due to pilot fatigue and disorientation. Despite efforts by the U.S. Air Force to keep these incidents under wraps, news leaked out. In November 1988, the Pentagon publicly disclosed a grainy, retouched photo that revealed very little of the F-117. Twice, stealth fighters were on the verge of bombing targets in Libya, but the missions were canceled to maintain secrecy. It wasn't until December 1989, during Operation Just Cause, the U.S. invasion of Panama, that the F-117A saw its first combat. During the operation, 6 Nighthawks flew to Panama via Texas and the Caribbean Sea, with 2 serving as backup aircraft and turning back unneeded. 2 others were assigned to support special forces attempting to capture General Manuel Noriega, but that mission was canceled. Confusion over a last-minute change led to a mix-up regarding the remaining target, a barracks housing 2 battalions of elite enemy troops. The goal was to stun rather than kill. The lead F-117A achieved this with a single 2,000-pound Mark 84 bomb. Known colloquially as the Hammer, the bomb, capable of a lethal radius of 400 feet and blowing out eardrums half a mile away, exploded in a field beside the barracks, causing significant confusion among the Panamanians. The second stealth jet also hit its target, although it was the wrong location. Nonetheless, the Air Force deemed the mission successful, as the stealth jets remained undetected by Panamanian radar. On August 17, 1990, Colonel Al Whitley took command of the 37th Tactical Fighter Wing. 4 hours later, he recalls, "The word came in to deploy our first squadron. The U.S. and its allies planned to remove Saddam Hussein's forces from Kuwait. King Khalid Air Base, located 6,500 feet up in the mountains near the Red Sea and nicknamed Tonopah East, had been constructed in the late 1970s in exchange for delivering McDonnell Douglas F-15 Eagles and AWACS airborne radars to Saudi Arabia. Because the base was beyond the range of Iraqi Scud-B missiles, the stealth jets required 3 mid-air refuelings to reach their primary target, downtown Baghdad.
"I generally put the F-117s against the Baghdad targets," said the Air Force's chief mission planner, Brigadier General Buster C. Glasson, where we would have lost conventional airplanes. The mission team included only 3 combat veterans, Whitley, his deputy commander, and 1 pilot from Operation Just Cause. However, after 5 months of intense training over the barren Nevada desert, the Night Stalkers and Ghost Riders were ready. They carried 2 tons of bombs, each over more than 1,000 miles of desert at night. Shortly before 3 a.m., local time on January 17, 1991, 8 stealth jets arrived above Baghdad with lights off and radio silent. Captain Marcel Kerr-David was tasked with bombing the Al-Kark Tower. Even though I felt very well prepared with my training, I was somewhat apprehensive about the aircraft. He later admitted, "Its stealthiness had not been tested in combat, and everyone wondered whether or not this stealth stuff really worked." Does the U.S. military have a new black aircraft program in development? Since the mid-1980s, the aviation press has been scrutinizing Pentagon documents and eyewitness accounts, suggesting a new stealth fighter for the next century. In February 1985, the Pentagon budget request accidentally listed a project alongside Lockheed's SR-71 Blackbird and U-2 spy planes, under the code name Aurora. This may have been a ruse similar to the F-19 ploy, as Aurora was also a name for a maritime patrol aircraft developed for the Canadian military. However, while the Canadians received their Auroras, the Pentagon's Aurora project reportedly continued, with funding rising from $80 million in fiscal 1986 to approximately $2.3 billion by 1987. Typically, the Air Force had no comment on the matter. However, by 1988, it was rumored to be working on a replacement for its SR-71 reconnaissance aircraft, which it retired with surprising eagerness in March 1990. Artistic renderings, some perhaps intentionally misleading, depict Super Blackbirds weighing over 150 tons, powered by variable cycle turbo ram rockets burning liquid methane or hydrogen, cruising the edge of space at Mach 6. Eyewitness accounts suggest that Aurora, if it exists, is more modest in size, but not necessarily in performance. In early 1990, Aviation Week and Space Technology reported unusually loud nighttime air traffic over Edwards Air Force Base in California, with one source describing the noise as the sky being ripped open. In June 1991, a sonic boom similar to those produced by space shuttles re-entering the atmosphere and strong enough to be detected by seismographs rumbled across Southern California. Judging by its sonic footprints, the object was flying toward the vast Nellis Air Force Range at speeds exceeding Mach 3. Activity seems to be concentrated around the remote Machrihanish Air Base in western Scotland, which was linked to the F-117A before the Nighthawk was publicly known. In November 1991, a Royal Air Force air traffic controller reportedly saw a radar blip leave Machrihanish traveling at Mach 3. Additionally, in August 1989, an engineer on an oil rig in the North Sea witnessed a mid-air refueling operation involving a mysterious aircraft shaped like an isosceles triangle when viewed from below. One thing is certain: design teams like the Skunk Works are always pushing the boundaries of innovation. Anticipating a barrage of anti-aircraft fire, mission planners assigned a second stealth jet to mark Kerr-David's target and reduce his workload. As the laser beam illuminated the dome-shaped roof of the Al-Kark, a forward-looking infrared radar, or FLIR scope, in Kerr-David's plane detected the signal and displayed it on the cockpit's 8-inch video screen. Using a fingertip control on his throttle stick,
David locked his aim point onto the laser reflection, and his weapons system projected an imaginary basket above it, guiding where the bomb needed to be dropped for a successful strike. 10 seconds before release, David pressed the pickle button to activate his weapons system. The Nighthawk's bomb bay doors opened, and its lethal payload, a 1-ton GBU-27AB guided bomb specifically designed for the F-117A, was released into the slipstream. With the threat of anti-aircraft fire mitigated, David, who was later awarded the Silver Star for his action, dropped his bomb from a relatively high altitude and close to the Alcarc. He then veered north towards his secondary target, a command bunker in the Taji suburbs. Meanwhile, the second F-117 remained on station briefly, using its belly-mounted downward-looking infrared radar, or DLIR, laser designator, to mark the target for David's bomb as it descended. In their room at the Al Rashid Hotel, CNN reporters picked up the sound of an air raid warning. "Now the sirens are sounding for the first time," Peter Arnett noted. "The Iraqis have informed us." At that moment, as if from nowhere, David's GBU-27 struck the Alcarc Tower, drilling halfway down before detonating. The building split in half, an event missed by CNN viewers and personnel at King Khalid as the network immediately went offline. An audio-only land link allowed Peter Arnett to describe the blinding spray of aimless return fire rising above the Baghdad skyline, while the Iraqi gunners' radars showed no aircraft above them. Seconds later, another F-117A's GBU-27 hit directly across the Tigris from the Alcarc. It penetrated the roof of the 12-story Baghdad International Telephone Exchange, known to Air Force mission planners as the AT&T building, the only target in the city scheduled for a double hit. Major Jerry Leatherman of the 415th Tactical Fighter Squadron, one of those planners, circled in from the northeast 60 seconds after the first strike. He dropped 2 high-blast Mk-84 bombs from 3 miles up through the hole in the building's roof. The first bomb landed slightly low, but the second hit perfectly, together demolishing the top 4 floors. In rapid succession, 3 waves of stealth jets struck their targets with a precision that was both merciful and ruthless, targeting the Iraqi Air Force and Ba'ath Party headquarters, Air Defense Control Centers, Rashid Airfield, and other high-value objectives, including 2 of Saddam Hussein's presidential palaces. Within half an hour of the initial strikes, Baghdad went dark, likely due to the destruction of the power grid rather than Iraqi countermeasures. Despite the blackout, the city remained illuminated by the persistent anti-aircraft fire. Back at King Khalid, ground crews anxiously counted the returning aircraft, with the last arriving only after dawn. Remarkably, every Nighthawk returned safely without a single scratch. In the first 24 hours of the war, the 42 stealth fighters at King Khalid, just 2.5% of the total Allied aircraft deployed in the Gulf, were responsible for 31% of the targets attacked. Damage estimates were lower than anticipated, partly due to a low mist obscuring Baghdad at dawn. Additionally, the cloud cover, which was 3 times the seasonal average during the war, not only interfered with subsequent operations, but also compromised the jet's stealth capabilities. "If you're just above a cloud deck with the moon reflecting off it, you can really stick out," explained Leatherman. At one point, an F-117A was shadowed by what seemed to be an Iraqi Dassault Mirage F-1 fighter, which was shining a landing light or spotlight to visually acquire the stealth jet. A slight maneuver, however, broke the lock, making it the closest any Nighthawk came to a dogfight over Iraq. Throughout the Gulf War, the Black Jets were consistently tasked with the most perilous, high-priority targets. These included radar sites, SAM and Scud launchers, enemy command control communications facilities, bridges, hardened aircraft shelters, and bunkers. Their data recorders captured some dramatic video footage for Air Force publicists. Notable examples include a hardened Scud storage facility destroyed by a laser-guided bomb dropping through an air duct, a bomb blowing in the door of an ammunition bunker followed by another bomb exploding inside, and a GBU-27 descending an elevator shaft to detonate deep within the Iraqi Air Force headquarters, demolishing all 4 walls. Ultimately, the F-117A Nighthawk's precision strikes played a crucial role in minimizing collateral damage and saving lives on both sides during the Gulf War. By successfully handling more than 40% of the coalition force's strategic targets, the Nighthawks demonstrated the effectiveness of stealth technology and precision bombing. The success of the F-117A led to significant changes in U.S. Air Force tactics and technology post-war. The 37th Tactical Fighter Wing, redesignated the 49th Tactical Fighter Wing, relocated from Tonopah to Holloman Air Force Base, New Mexico. Air Force analysts have so far found no way stealth technology can be compromised in the foreseeable future. In any case, the F-117A Nighthawk, the Skunk Works, and Ben Rich are assured their places in aviation history. We guaranteed to deliver an aircraft which would have stealth characteristics, be virtually undetectable by today's known radar technologies, and be able to deliver a weapons system with unprecedented accuracy, said Rich. We've done that. Our accomplishments speak for themselves.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunk Works' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. for more amazing aerial footage. And to join us in this incredible journey, check out the Dronescapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.